Hi class, how are you today? You know I can't hear you, right? Anyway, we have two learning targets today. First, to solve multi-step equations, which we've been working on, and now to determine the number of solutions of an equation. This will deal with some special cases. So before we start, I want you to take out the steps that I gave you last time. If you don't have them, you should probably write them down, and here they are again. We're going to use these throughout the lesson today, so I want to make sure you have them to look at whenever I talk about them. I'm not going to rewrite them again through the lesson, so make sure you have them written down and can look at them at any point. So let's look at this first example. In this first example, let's go through the steps like we have been. Step 1 is distributive property. That only happens if there are any parentheses around. I don't see any, so we can skip that step. Step 2 is combine like terms. So first let's look what terms are alike. On the left side we have x and we have a positive 2x. Those are alike, and with the numbers that are by themselves we have a positive 3 and a positive 4. On the right side, we have 5x, a positive 5x, and a positive 6x. And for the numbers, we have a positive 7 and a positive 8. So then we combine the like terms. X plus 2x will give us 3x, and that's because we say that there is a 1 in front of the x if it's ever by itself. So that's actually a 1x. So that's the x's on the left side, and then 3 plus 4 is 7, and then that equals, on the right side, we have 5x plus 6x is 11x, and positive 7 plus 8, 7 plus 8 is 15. The next step would be step 3, which is to undo division of the entire expression. There's no division happening, so we can skip that step as well. Step 4 is to bring the variables to the same side. So we look, and we see that there's a 3x on the left side and an 11x on the right side. So we want to take the smaller one, the 3x, and we want to subtract the 3x from both sides of the equal sign. We take the smaller one, so we'll end up with a positive number. It's easier that way. So we subtract 3x from both sides of the equation. The 3x's will then cancel each other out on the left side to leave just 7. And on the right side, 11x minus 3x is 8x. And the plus 15 stays there. The next step is step 5. And actually, just as a disclaimer, step 5 and step 6 are actually the same thing, and I accidentally wrote it twice. But there's no harm in having it on there twice. You just use one and skip the other. Anyway, so bring the constants to the other side by undoing the addition or subtraction that's happening to the variable. So if you look here, we've got 8x plus 15. So that means we want to get rid of this plus 15, so we subtract 15 from both sides. Seven minus 15. Remember, if they're different signs, you subtract them and take the sign of the bigger number. 15 minus 7 is 8, and 15 is negative. The bigger number is negative, so it's a negative 8. And then that equals 8x, and the plus 15 and minus 15 cancel out. So that's just gone. So we're left with negative 8 equals 8x. So then we're down to the final step. Step 7 is undo multiplication or division. So we want 8 times x, so we want to undo that. So we divide both sides by 8, and we get x equals negative 1. And that's our answer. Most problems you'll deal with will look like this, where you have one answer, or specifically one solution. Most of the answers we've dealt with so far have been one solution. X equals a number. Today I'm going to talk about other special cases that you might come up across. Let's look at the second example. We have 3 times in parentheses x plus 4 equals 3x plus 11. So let's again go through the steps. Step 1 is the distributive property. That's where you have a number in front of parentheses. Well, if you look right here, we have a number in front of parentheses. So that's the first step you want to take, distributive property. Remember, if you have a number in front of parentheses, you take that number and multiply it by both numbers inside the parentheses. So first we have 3 times x, which will give us 3x, and 3 times 4, which will give us 12. And the rest of the equation drops down. Step 2 is to combine like terms. Well, let's look at the left side. We have something with an x and just a number. No like terms on this side of the equation, so we can't combine anything. On the right side, we have something with an x and just a number. Again, no like terms on this side. Step 3 is to undo division of the entire expression. Again, there's no division happening here, so we don't have to worry about that part. Skip that step. Step 4, bring variables to the same side. So we want to take the 3x on the left side and subtract it from both sides of the equation. And 3x minus 3x cancels out, just becomes 0. So on the left side, all we have is 12. And that equals 3x minus 3x. Well, again, those are the opposites, so they cancel out, just becomes 0. And all we have on the right side is 11. 12 equals 11. Does 12 equal 11? No, it doesn't. 12 only equals 12, and 11 only equals 11. 12 does not equal 11. So when you have a number that is equal to another number that's not itself, this is where you write no solution. And I talked about this in a previous video. This is one of the special cases. So there's no number you could plug in for x that would make this equation true. Alright, here's the final example that I'm going to do today. So let's go through the steps again. Step 1, distributive property. No parentheses, skip it. Step 2, combine like terms. On the left side, something with an x, just a number, no like terms to combine. Right side, something with an x, just a number, no like terms to combine. So we can skip that one as well. Step 3, undo division of entire expression. No division happening, skip that one. That stuff will happen a lot where you have to skip a lot of steps. You'll see that. And those are usually the easier problems. The harder ones usually have to do with a lot more steps. But sometimes you'll just skip a lot of these steps. So this brings us to step 4. Bring variables to the same side. So, like we did in the last equation, subtract 2x from both sides. The 2x's will cancel to leave just 3 on the left side, and that equals the 2x's on the right side will also cancel to leave just 3 on the right side. Well, our x disappeared again, and we're left with just 3 equals 3. Does 3 equal 3? Why, yes, it does. So, we've got a number that is equal to itself. This is one more special case. And the answer that we write down here is infinite solutions. We say infinite solutions because there's any number you plugged in for x, it would work for that equation. And the reason it kind of works is if you look up back at the original equation, we had 2x plus 3 equals 2x plus 3. It's something equal to itself. So that's a little hint that it's going to be that, but you always want to solve it out because sometimes they're hidden and there'll be different ways that they actually do equal themselves but won't show it. And it won't be this easy right out. So, if you end up with a number equal to itself, your answer will be infinite solutions. So, just to recap, there are 3 types of solutions you can have. The most common one you can have is one solution, and that'll always be if you end up with an answer of x equals some number. Let's say -7. But it'll always be x equals a number. Any number, but it equals a number. No solutions will be when you have some number, let's say 8, is equal to some other number, let's say 12. 8 doesn't equal 12, so that's when you say no solution. And infinite solutions is when you have some random number, say -5, and that's equal to itself. Also -5. So those are the 3 different kinds of solutions you can have and what sort of answers they will look like. Those are the only ones you can have. You'll have x equals a number equals some other number, or a number equals itself. If you end up with one of those 3, you know how to answer it. Alright, that's it for the lesson today. As always, I will see you next class. Make sure to take notes on this. It's your homework grade. So take notes on the entire video and bring them to school, and I will see you next class and check them and hopefully give you all 100s. Have a good night.